Hello and welcome again to this YouTube channel. Okay, so now our intention is to find the extremum point, okay, for this, for example, for this function. Okay, in the earlier YouTube video, okay, if you notice, we are just focusing on finding the critical point. Okay, but in this video, how to detect whether your critical point is a maximum or whether it is a minimum point. All right, so this is how we're going to solve. Okay, so first things first, you cannot shy away from finding your critical point. All right, so as earlier we mentioned earlier, this is what you get. Okay, you just solve this equation. Okay, now, what's interesting? Okay, you look at this one. Okay, there are lots of x leaf, and then you put this one equal to zero because you know you want to find the critical point. Okay, and then once you have this, you can see your x is still a lot. Okay, you try as best as you can to simplify this function, these results that you have. All right, so you have 12x, and then once you factorize your x, this is the only values that you have. And then you can see in the bracket, you can always simplify it again. All right. So your simplification of this would be something like this. Okay. All right. So from here, you know that, okay, your first critical point is 0. Okay, your second critical point is 3. Okay, and your third critical point is 1. All right, so you can also find the corresponding points there, meaning that your first critical point is 0, 0. Your second critical point is 3, -27. Okay, you plug in your s equal to 3 into your original y, and then the latest one, you have another, sorry, yes, you have another point there. Okay, so this is 3 points. Okay, now we want to see whether our point now is a positive or is it a negative or what. All right, so this is the idea of we call that a first derivative test. Okay, as the name mentioned, meaning that you need to use your first derivative. Okay, and then you test your first derivative. Okay, the value for your first derivative. Okay, so how can we do that? All right, so first things first, you need to see. Okay, I'm putting it in a line like this one. Okay, and you imagine this one is your x line, and then you put back all your x's in this value. Okay, first I have one critical value over here. My x equals to 0. And then I have either x equal to 3 and also 1. So I put 1 first. And then I put 3. Okay, now it becomes interesting. Okay, why I said it is interesting? Okay, we want to see how is it, okay, the behavior of your first derivative nearing your 0, 1, and 3. Nearing meaning that this is, you have this one. What is the first derivative behavior in this segment? What about this segment? What about this segment? This segment, this segment, and this segment. Okay, if you notice, I put a very small segment over here because this is what we call a relative. Okay, relative meaning that you just want to find the neighboring values. Okay, in this case, the first derivative values nearing your critical points. Okay, so how to do just that? First, we select one point over here. Let's say the neighboring value over here, I select -1. And then the neighboring part over here, I cannot select 1 because 1 is a critical value. Okay, so I select something smaller. Okay, settle for 0. What about the neighboring value for that? I think I can share this value, 0.5. And then I introduce 2 because 2 is near to 1 but it is not a critical point, so you can, just similarly you can just share it. Okay, and then what about 3? The neighboring, we also use number 2 over here. Okay, just to cut things short. And then we select another value over here for my neighboring part on your my 3. Okay, on my neighbor in my right hand side of 3. Okay, all right. So now it gets interesting. As the name mentioned, you need to find the first derivative because you want to test. Okay, you want to test the first derivative. You're not testing your y and you are not testing your critical point. You are testing your first derivative, meaning that you are testing this value. Okay, once you test this value, meaning that you need to put your value -1 over here inside your dy dx. Okay, if I can put something like this over here first. Okay, if let's say I want to know, okay, what happened to my dy dx when I put the value x equal to -1 inside my dy dx. Okay, so meaning that I have this -1 cube minus 48 -1 okay. All right, so I show you one example here and then later you can solve the other. All right, so if you calculate this, okay, la 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 la, and then actually you get, using your calculator, you get -96. Okay, I just put over here. Okay, for example, -96 over here. Okay, and then you know negative is a negative sign. Negative meaning that it's like this, right? Okay, sorry. All right, you put negative sign you put negative sign like this. Okay, you put negative sign like that. Okay, and then whatever happen, if you put the same one, okay, you put dy dx, okay, the first derivative. Now your x becomes -5. Okay, when you calculate and all, okay, I simplify the calculation over here. I will get 7.5. So this is the positive. This is the positive also because it shares the point values. And then what about my 2? Okay, x equal to 2. I calculate and then I get -24. Okay, so I put negative sign over here, and since it is sharing the values for my 3 as well, the same thing for my 3 on my left hand side. And then when I put x equal to 4, I have 144. All right, so this is my positive value. Now it becoming quite interesting now, right now, isn't it? Okay, so we go back to our understanding of uh, our slope. Okay, our slope, because we know the definition of my dy dx is just a slope, right? So if let's say I have a value, okay, if I have my slope negative slope, for example, what does it mean? Okay, it means that this is my form of my slope, right? Okay, because this one is a negative value. If I have dy dx that is positive, my slope is like this, right? Okay, so you use this idea, you can see over here. Okay, oh, it's becoming very messy. Okay, but I think you get the picture. Okay, so I put something like this. Okay, easier for you to see. Okay, this one is my critical points. Okay, so I can move it at the back over here. So my slope negative is like this. The other one positive is like this. Okay, this one is also positive is like this. And then negative is like this. This one negative is like this. This one positive is like this. And if you put the line together, your slope is like this. And then from over here, the critical point, you know it is like this. Okay, so it changed like this. So the same thing you can imagine like this, and then it changed like this, and it changed like this. And then from this side, you can see, okay, now you can see, oh, actually my, I don't have the time, I don't have the place now. Okay, so I can see now for my, this point, okay, this is actually a minimum point for this one, the 3, okay, 3. This 3 is also the minimum point. And then the 1, the maximum point. Okay, this is my maximum point. Okay, so it's a little bit messy, but if you do not understand the first time around, okay, you need to watch this video so that you get a little bit of more information on the second or on the third watch of this video, because I know if you look carefully at the steps, you can get what we mean by this. All right, so I hope you enjoy the video. I'll see you guys in the next video. All the best.